So far we've done a couple of examples here, and I just won't, we've kind of talked about the horizontal asymptote. Okay, for ourselves. Okay, and we could, before we could look at a couple of graphs here, right, and start to predict it. So what we're going to do is take each of these functions for yourself. Okay, so take each of these, put them into your graphing utility or your Desmos, and look at the graph, and then use the graph to find the horizontal asymptote. So pause this video, put each of those three in, right, and then write out where your horizontal asymptotes are. Okay, now that you've actually done it yourself and you've looked at the graphs, if you haven't looked at the graphs, look at the graphs first. Right? This one, what's happening to this as we're approaching infinity? Okay, right? Well, we can see that as it's approaching infinity, right? This was equaling 1, so our horizontal asymptote for this one was y equals 1. Okay. For this guy right here, right? What happened? Well, as we were going, right, there was no horizontal asymptote. Okay, no horizontal asymptote for yourself. For this one, the horizontal asymptote was at y equals 0. Okay, so let's think about why each one was what it was. Okay, for f of x, y was a horizontal asymptote, y equals 1. Okay, well, if we take a look at f of x there, and if we're going to plug in, let's do the limit as we're approaching a billion, right? And I talked about this in one of the other videos as we did it, but let's think about it. Look at the top function. If you're plugging in really large numbers, what really matters here? Not -1, right? That matters if I'm, if I'm plugging in 2 or 3, but not when I'm plugging in 1 billion, 1 trillion, 1 quadrillion, whatever, right? Subtracting 1's not going to really affect anything. Right? Think about a billionaire. If a billionaire gave you $1, how much would that really matter to their overall bank account? It wouldn't matter very much at all. But if you only have $10 in your bank account and you give away $1, then you're like, oh geez, that's a lot. That's a high percent of my money. Right? So you don't want to give away that $1. You want to hold on to every dollar you have. Right? But if you're a billionaire and you're giving away $1, it's nothing. That's like you giving away a penny. Right? You're like, whatever, just a penny. Okay, that's how a billionaire looks at $1. Right? So we can ignore that. We have that. Okay, the -1 doesn't really matter for the denominator. Then we also look at it and say, okay, I'm going to take a billion and square it plus a billion. And I showed you in that previous video, hey, that a billion squared is a billion times larger than this. So how much does this really matter? Adding a billion to a billion, it doesn't really affect anything. Okay, I'm sorry, adding a billion to a billion squared, right? It's the same idea as what we're just talking about, right? But let me just show you in case you're like, well, I feel like you can't just ignore a billion. You can, right? If that's a billion squared and you're going to add a billion, and the general magnitude of that problem, how much did you really add? Not much. It's like adding $1 to a billion. That's really the equivalent. It's like adding $1 to a billion. It doesn't really affect your overall bank account very much. The percent that it affects is so little. Okay, so for the numerator, all that really mattered was this. For really large values of x, this is all that really matters. Okay? For the denominator, do the same thing. How much is -4? Does not matter. If you're plugging in a giant number like 1 billion or 1 quadrillion, how much does it matter if you subtract 4? Very little. How much does it matter if you add 5 times a billion if you already have a billion squared? Well, that would be like this, but having a 5 right there. How much does it matter to your overall percent of money if you add $5 to a billion? Doesn't really matter much. So that doesn't matter. This is all that matters. So f of x behaves like x squared over x squared over x squared for really large magnitude numbers. Okay? This is called the end behavior. At the ends of it, what is it behaving like? It's behaving like this function. Right? Well, x squared over x squared reduces to 1. Your horizontal asymptote. It's behaving like 1. It's getting infinitely close to 1. If we look at g of x, right? Horizontal asymptotes, they only care about what happens in the very, very end, the end behavior, the very large numbers. So, if we're thinking about what really matters as x is getting larger and larger, what really matters, not 5, not negative x, what really matters is the x cubed. For the denominator, what's going to eventually take over? Adding 1,000 matters if you're at x values of 1 or 2, but not when you're at 1 billion and you took that 1 billion, you squared it. Right? So the 1,000 doesn't really matter. Subtracting 5 times a billion doesn't really matter when you have a billion squared. So really what takes over is the x squared. So g of x trends to this right here, which reduces to x. So if we're going to do a limit as g of x, if we're thinking about what's happening to this function as we're approaching infinity, it's going to behave like this. And that's going to equal infinity. And if we're thinking about negative infinity, well, that limit's going to be negative infinity. Okay? So, technically those aren't even limits. Like your limit technically has to equal an exact value there for ourselves. So that doesn't really help us at all, right? That means that as it's getting larger, it's going way up or way down. We look at h of x for me and think of the same thing. What's happening as we're approaching really, really large values? Okay, what really matters for the top? It's just the x. For the denominator, what really matters? Not the 2. Not the 4x. When we have a billion cubed, how does it matter if I have 4 times a billion? It doesn't. So this is what takes over. If I reduce that, I can see that my end behavior model, my function that takes over is 1 over x to the 4th. If I think about the limit of that as x approaches positive or negative infinity, well, that's going to be 0. Our horizontal asymptote that we talked about up there. Okay? Right? So think about these. Right? We could graph these out and look at the graphs, but you want to look at the function and kind of understand what the function is doing when you're trying to find these horizontal asymptotes.